You are Jon San Pedro and Dirk Jan van de Ven from the Basque Center for Climate Change, and we will be working with the GCAM model in this project, also together with Rina from the University of Maryland. And we'll just present like the model here. So GCAM is a community model, which is a completely open source already from for about a decade now, I think. And it's developed by the joint Global Change Research Institute, which is a part of PNL and the University of Maryland. The model is a partial equilibrium model, which is designed to explore like dynamics between human and earth systems. So between energy, economic energy and affluent systems, water and emissions, and climate systems. And with the intent to have everything completely dynamic. So all these different systems influencing each other to with the purpose of modeling like scenarios, policies, like interdependent to see like how interdependencies between the different systems develop. The model has been widely used. I think a lot of people have heard of the name of the global change analysis model. But by the way, it was called the global change assessment model before. So just not to confuse you, but it's widely used in IPCC scenarios, in SSP pathways, and also the RCP pathways. And many multi-sectoral, multi-skill studies and reports. And in this specific project, we use the GCAM model or as it is, or we can also make some adaptations. So we call it like the GCAM compact version, because, for example, for the first task on the gas crisis, we also have some adaptations that we will make, and maybe for other policy questions, we can also make adaptations. Jon will now present like the structure of the model.
Yeah, so basically just I wanted to give like an overview of the model structure and then some of the systems. So here you have like a diagram that summarizes like the overall behavior of the model. So the model like reads in the economic activity or the economic variables, and then includes some markets and equations, and tries to find an equilibrium between the supplies and the demands. So then you have like the model produces like a vector of prices on equilibrium, and then you have all the quantities in terms of agricultural, energy, and water demands, and then like produces the climate outputs. And just to give a sectoral overview or how the model works in a more schematic way. So the model like reads different key assumptions. For example, I have divided them in some blocks. We have like the socioeconomic assumptions, which are the main driver for the economic activity, the population and the GDP growth. Then you also have to set which are the cost and efficiencies now and in the future for different energy technologies. Also have to set like agricultural or land cost, yields, profitability, water or fertilizer requirements, or different the carbon contents for different land types. Also water runoff and availability. You also have to set like the renewables or the depletable resource supply curves. And also you can set like which are the policies in place, like emission controls or different sectoral policies or temperature limits. So these are like based on the different sources or data that there is already available, or making like some future assumptions. We set that into the model, so the model then solves with the market equilibrium, and then you have these different outcomes classified in different blocks. In terms of energy system, you have demand and flow, energy mixes. You also have like the AFOLU outcomes in terms of land allocation, forest production, food and feed demand balances. Also have water withdrawals, also some emission outcomes in terms of GHG pollutants. You have also some climate outcomes like radiative forcing or temperature increases or CO2 concentrations, and also some economy outputs, right, in terms of policy cost or carbon prices, but always remembering like the GDP and population are exogenous and are an input for them. Just very briefly, the different systems. So first, this is the regular regional coverage of the model. So we have 32 geopolitical regions and also 235 water basins, and the interaction between the water basins and the regions creates this 384 land lands for that are going to be relevant for the land outcomes, and one global regions for the climate, right? Just a note that as Dick was mentioning, in our GCAM Ion Compact version for the first tag, we will have some flexibility on this, and we are testing this model version with some additional European regions. So instead of having 32 regions for this GCAM Ion Compact at the beginning, we will have kind of 38 or something like that, right? So in terms of energy system, like the model goes from resource production to energy transformation, then we have some final energy carriers and finally some end-use energy demands, right? So this is like the schematics here. The model will have like different cost and input-output coefficient, like for example, how to go from oil to liquid refining and how that transforms into the market that then is going to be demanded by the different end-use sectors. So here is the schematics. I don't want to enter into much details on here. Same for land, like land system in GCAM has this like different nesting structures. So we have like land divided in four main blocks, with some of them are exogenous, some of them are endogenous. Then we have like this kind of different nesting with pasture and non-pasture land, and then a final nester that we have like grasslands, croplands, forest land, and then between commercial and non-commercial land, right? So this is like the big scheme on the left, and on the right is, I know that it's very small, but wanted to represent that, for example, like different croplands have also additional details in terms of if the cropland is on a rain-fed or an irrigated land, and then you will have another nest that will represent it is high or low fertilizer use. So it's like you will have like different nests, but also we have a lot of detail in terms of which in terms of the production of each crop is going to be on different, we'll have some nest under that, and you will be able to see if the production of corn in one land region will be in irrigated land or rain land or high fertilizer land or low fertilizer land. So this is more like the scheme of the land. Same for the water system. So the model, as I was mentioning, was in the regular version has 235 water basins, and how the model like first incorporates some data coming from an hydrological model. So the model has the global water runoff, and that is transformed on renewable water supply. Then we also include some non-renewable water supply that has some supply curves that are set into the model, and then also some assumptions for desalinated water. And the three water supply options go to the water supply for agriculture and for non-agricultural uses, for example, like municipal water, right? So this is like how is structured the water system that interacts with it. And finally, to make it in 10 minutes, the model has also like monitors or reports the main emissions for the main GHGs like CO2, methane, N2O, but also like HFCs and the main air pollutants like NOx or primary PM2.5 in terms of black carbon and organic carbon. We have SO2, NOx, and different main air pollutants and ammonia. And then these emissions, like GCAM also incorporates a simple climate model, which is Hector, into the modeling framework. So GCAM produces emissions, and these emissions are fed into Hector, which is incorporated also into the model. And this model like reads in the emissions are produced and produces like the main outcomes that Hector produces that are in the context of the project would be radiative forcing, CO2 concentrations or temperature, but also produces like other land sinks in terms of vegetation or detritus of soils, and also some ocean outcomes, like you have like temperatures and ocean uptakes and these kind of things that are more related to Earth system model. Right? So this is like the models of the system that we have in the model very briefly, and we'll be happy to answer any question that you may have later, but they will explain which are like the uses of the model or the applications in this project.
So in the model we can apply different types of policies. So these policies will lead into the type of output that you mentioned. So if like directly on climate, so carbon taxes or GHG emission constraints. Also like energy system policies on tax subsidies, renewable energy targets, or energy intensity standards, or like efficiency standards. And also on the land system, we have policies like land constraints, example, like afforestation, minimum afforestation levels, constraints to bioenergy, text of land use emissions, or land protection. And the model has been used in the past for like some very different kind of research questions. So like simple, like the clear ones that all the IAMs do, like how climate pledges limit global warming. And other questions like on SDGs, what implications have different scenarios to mitigate. Also the kind of multi-sector effects of deployment of energy technologies. So for example, also what we have been working on, like the impact of solar energy on land use, like this kind of effects. Then the consumption of welfare implication of so the other way around a bit, like agricultural productivity changes due to climate change or other effects like ozone. How does it affect like trade and consumption? Then also pathways with SSPs, so shared socio-economic pathways. How do they affect the different the outcomes of mitigation scenarios? And finally, like food, energy, water implications of different technologies, like also negative emission technologies. And in terms of SDGs, we also have one paper where we kind of map like different SDGs, like the indicator used and how GCAM kind of responds to these SDGs. For example, food in zero hunger, the food price, the agricultural yield, all kind of things. So also like will the forest cover for like the life on land SDG. And in some cases we also we can mix GCAM with another tool like RFAST, which is used for like the impacts of pollutants on, for example, health, or on ozone pollution, on yields, or like on hectare, like the full hectare model for to see like the impacts on ocean acidification. And finally, GCAM has quite a good documentation, quite a complete documentation. Although, of course, for use, it's a lot more. You will have always a lot more questions, but like to see the overall overly how the model works, we have there are some public documentations. Actually, we didn't mention here the I'm to Paris platform, which also has like documentation on the model. So thank you.